Welcome to Lesson 1, Role Foundation. In this lesson, we will answer a basic but important question. What is a forward deployed engineer? If the title sounds unfamiliar, start with the work, not the unfamiliar title. Imagine that IST Field Services maintains commercial equipment for hundreds of customer locations. When a machine stops working, a service coordinator reads the incident, checks several systems, decides which technician should respond, and gives that technician the right context. Today, this process is slow and inconsistent. IST asks for an AI assistant that can recommend the next action. That request contains three different things. First, a customer problem. Coordinators are losing time and making inconsistent decisions. Second, engineering work, software, data access, integrations, permissions, evaluation, and operational support must be designed. Third, a measured result. The deployment should reduce resolution time without creating unsafe recommendations or hiding important evidence. A normal product team might own the reusable platform. A customer team might own the workflow. A sales team might describe the desired outcome. But this deployment crosses all three. Someone has to stay close enough to the customer to discover what is actually happening and technical enough to build and operate a reliable answer. That is the space in which an FDE works. Keep this three-part test in mind throughout the course. Customer problem, engineering work, measured result. If one part is missing, the engagement is not yet defined. A demo without a measured result is only a demonstration. A customer request without engineering evidence is only an assumption. And code without an understood customer problem may solve the wrong thing perfectly. Here is our working definition. An FDE is a software engineer who works directly with customers and helps turn an operational problem into a working, measurable deployment. Every part of that definition matters. Software engineer means this is an engineering role. An FDE may write application code, integrate APIs, query databases, design service boundaries, debug authentication, build evaluation harnesses, inspect logs, deploy changes, and respond when the system behaves differently in production. The exact stack varies, but technical implementation is not optional. Works directly means the engineer does not receive every requirement as a finished specification. Satish talks with IST coordinators, observes how incidents are triaged, checks what the source systems actually contain, and identifies who can authorize a workflow change. Customer proximity is an evidence source. It does not mean accepting every request, bypassing product discipline, or promising custom work before feasibility is known. Operational problem means the work begins with a real decision or workflow. IST did not wake up needing a model endpoint. It needs coordinators to resolve incidents faster and more consistently. The model may become one component, but the deployment also needs current equipment context, service history, authorization, deterministic checks, user controls, audit records, monitoring, and a fallback path. Measurable deployment means the answer must operate in the customer environment and create evidence. For IST, we might measure recommendation acceptance, time to a correct dispatch, unsafe suggestion rate, missing context rate, and the percentage of incidents that correctly fall back to a human. If the system works only in a prepared demo, it is not yet a measurable deployment. So do not reduce an FDE to a customer-facing developer or a technical problem solver. The stronger definition connects customer proximity, software engineering, operational ownership, and evidence of impact. Now let us decode the title. Customer proximity changes where evidence comes from. Engineering determines how the answer is built. Forward deployed means the FDE is positioned close to the customer problem. That proximity may involve working on-site, joining customer calls, operating inside a dedicated delivery team, or collaborating continuously with users and system owners. The physical location is less important than the information loop. Satish can move from a coordinator's observation to an API trace, from an API trace to a product limitation, and from that limitation back to a scoped customer decision without losing the context at every handoff. Engineer means Satish is responsible for technical reasoning and implementation. Suppose a coordinator says, the assistant gave the wrong technician. An engineer does not treat that as a vague complaint. Satish traces the incident identifier, checks which equipment record was retrieved, verifies the technician roster timestamp, inspects the model input and structured output, runs the policy validator, and determines whether the failure came from stale data, retrieval, Model behavior, business rules, or the user interface. The two words must stay together. Forward deployed without engineer can become relationship management with no technical ownership. Engineer without forward deployed can become technically elegant work separated from the customer workflow and consequences. This combination is why FDE interviews and job descriptions often look unusually broad. Employers are searching for someone who can cross a boundary that their normal operating model struggles to cross. The durable signal is not travel, a particular programming language, or constant customization. The durable signal is technically owning a difficult customer deployment while preserving enough discipline to produce reusable learning. Why the role exists becomes clear when we inspect the deployment gap. The hardest work spans customer reality, product capability, integration constraints, and production ownership. Start with customer reality. IST initially describes the problem as recommend the correct technician. Observation reveals a different workflow. Coordinators first decide whether a technician is needed, whether remote troubleshooting is safe, whether a warranty restriction applies, and whether the equipment record is trustworthy. The original sentence hid several decisions. Next comes product capability. The AI platform may summarize incident notes, retrieve approved procedures, and produce a structured recommendation. It may not understand IST's proprietary entitlement rules, technician certifications, or regional safety policy. Satish must separate what the reusable product already supports from what belongs in customer configuration, an integration, a product enhancement, or an explicit limitation. Then come integration constraints. The equipment system may expose an API, but only from a private network. The technician roster may update every 15 minutes. Incident notes may contain sensitive customer information. Identity, authorization, data contracts, latency, rate limits, and environment access determine what can actually be built. A slide showing connected systems is not proof that those systems can support a production request. Finally, production ownership. After the pilot, who monitors failed recommendations? Who can disable automation? Who responds when a source schema changes? Who approves a new action type? Who owns the user workflow after Satish leaves? If those owners do not exist, the engagement has a demo plan, not an operating plan. Traditional handoffs often separate these four realities. Sales captures intent, product explains capability, engineering receives a ticket, implementation connects systems, and support inherits the result. An FTE helps keep the evidence connected long enough to make a defensible technical commitment. The durable FDE signal is lifecycle ownership. Satish remains accountable as the engagement moves from uncertainty to evidence. We will use a 6-stage operating loop. Understand the workflow before designing the answer. Satish observes coordinators, maps the incident path, identifies the business decision, names the system owners, and records contradictions. The output is not a wish list, it is an evidence-backed problem statement. Bound the engagement before making a commitment. Satish defines the users, incident types, allowed actions, data sources, safety constraints, success measures, and unsupported cases. For IST, the first thin slice may recommend one of 3 next actions for low-risk equipment incidents while requiring a coordinator to approve every dispatch. Build the smallest complete system that can test the important assumptions. That can include an incident API, identity and authorization, retrieval with provenance, a model contract, deterministic validation, a coordinator interface, audit logging, telemetry, and automated evaluation. Small does not mean incomplete where safety or operability is concerned. Operate the pilot in the real workflow. Satish watches traces, investigates failures, supports coordinators, adjusts runbooks, and confirms that the named IST owners can handle expected events. Production behavior creates evidence that a lab test cannot. Prove the outcome using the measures agreed earlier. Did handling time improve? Were recommendations accepted for the right reasons? Did unsafe suggestions remain below the threshold? Did fallback work? Did coordinators trust the evidence enough to use the system? Return the reusable learning. A customer-specific discovery may reveal a reusable connector, a missing product control, a better evaluation case, a deployment pattern, or a clear boundary the product should not cross. The FDE should not leave behind an unexplained custom branch. The work should improve the customer outcome and strengthen the reusable product or operating knowledge. Understand, bound, build, operate, prove, return. The FDE may collaborate with different teams at every stage, but does not discard accountability when the work crosses a team boundary. Lifecycle ownership needs a responsibility boundary. Ownership does not mean doing everything alone. An FDE owns clarity, decisions, and technical follow-through while sharing specialist work with named owners. Own the engagement evidence, the current technical path, and the unresolved decision log. Satish should be able to explain what is known, what is assumed, what has been tested, what failed, and what evidence would change the recommendation. Satish also owns following a technical issue across systems instead of dropping it because the root cause sits outside the first repository inspected. Share work that requires specialist authority. IST security owns its access policy. A safety owner approves actions that could affect equipment or people. Platform engineers own reusable service reliability. Product managers decide whether a customer need belongs on the core roadmap. Customer operations owns staffing and workflow adoption. Satish connects these owners and supplies evidence. Satish does not impersonate their authority. Escalate when authority, evidence, or production ownership is missing. Examples including credentials that cannot be provisioned safely, a requested action with no policy owner, a model quality threshold that cannot be measured, or a go-live date with no support rotation. Escalation is not failure. It is how an FDE prevents an unresolved organizational gap from becoming a hidden technical risk. Refuse commitments that the evidence cannot support. Satish should refuse to promise perfect model accuracy, unrestricted automation, an unsupported data source, or a permanent custom branch with no owner. A good refusal is technical and constructive. Name the missing evidence, explain the risk, offer a narrower test, and specify the condition under which the decision can be revisited. This boundary protects the role from becoming the person who does whatever the customer asks. An effective FDE is flexible about implementation, but disciplined about evidence, authority, and production responsibility. There is one complication when you explore this career. The title varies. Different employers shift the center of gravity without erasing the core lifecycle signal. In a product-led operating model, FDEs may work with a small number of strategically important deployments. They build with the customer, identify patterns, and return reusable capabilities to the product. Coding depth and product feedback may dominate the job. In post-sales delivery, implementation success may dominate. The role can include configuration, integration, data migration, customer enablement, and go-live ownership. This can still be strong FDE work if the engineer owns difficult technical decisions and measurable deployment outcomes. It becomes less like FDE work when it is primarily project coordination or repetitive configuration with no engineering responsibility. In an infrastructure-heavy environment, deployment architecture, networking, security, performance, reliability, and incident response may dominate. Customer proximity remains important because infrastructure choices must fit the real environment rather than a reference diagram. In an evaluation-heavy AI environment, model behavior, test datasets, human review, safety policy, prompt and retrieval changes, production telemetry, and release thresholds may dominate. The FDE may spend substantial time turning subjective user complaints into reproducible evaluation cases and measurable acceptance criteria. Therefore, inspect the operating model, not the label. Ask what percentage of time involves coding and debugging. Ask whether you work directly with users and system owners. Ask who owns production after launch. Ask how customer learning reaches the product. Ask what success is measured against. Ask whether deployments create reusable capability or accumulate unsupported branches. Two employers can use the same title for meaningfully different careers. Your task is to find the observable work underneath it. Let us finish with the lesson, decision. Can you define the role without using the title? Classify each responsibility using evidence rather than assumptions. A durable signal is customer to outcome lifecycle ownership. Working directly with customer evidence, making substantive technical contributions, following the deployment into real operation, measuring the result, and returning reusable learning are strong signals across different FDE operating models. A shared responsibility requires a named partner and handoff. Security approval, safety authority, core product prioritization, customer change management, and long-term operational ownership are usually shared. The FDE makes these dependencies visible and ensures the technical path respects them. An employer-dependent responsibility must be verified. Travel frequency, on-call duty, sales participation, project duration, cloud stack, model provider, coding percentage, and whether the role begins before or after a contract can all vary. Do not assume them from the title. Not supported means the claim should not be attributed to the role. An FDE is not automatically the sole owner of customer success, the final authority on security or safety, a substitute for a product organization, or a promise that every customer request will be built. Here is the one-sentence definition to keep. A forward-deployed engineer is a software engineer who works directly with customers and owns the technical path from an operational problem to a working, measurable deployment while coordinating the product and operational boundaries required to run it safely. For IST Field Services, Satish is not being asked merely to connect a model. Satish must discover the coordinator workflow, bound the assistant's authority, build the surrounding system, operate a pilot, prove the outcome, and return what the team learns. Before you continue, test yourself. What customer problem is being solved? What engineering work is required? What measured result will prove the deployment? Which responsibilities does the FDE own, which are shared, and which depend on the employer? If you can answer those questions, the title is no longer mysterious. You can inspect the actual work.